We have our our segment addition postulate that says we can take each piece, add it together to get the whole. And we know now the length of AB. Granted, we don't know the exact number, but we know an expression that could give us the exact number. We know that for both segment AB and segment BC. And we have an exact number for the segment AC. So let's substitute in what we know. We know that the measure of segment AB is 2x plus 6. We know that the measure of segment BC is 4x minus 2. And we know that the length, of segment AC is 28. So now we're going to do our algebra funness to it. I'm going to pull out some more colors here just so that we can keep track of what's going on. Reading my daughter's gel pen stash. Okay, I've got tons of colors going on now. All right, so when we look at this algebra thing, in order to solve algebra equations like this, I'd like to make sure that we line up the equal signs. So every time I write a vertical step, I'm going to make sure that that equal sign stays right there on that vertical line that I sketched with my pencil. That's also kind of acts like a wall, so that way you can think about the left side and the right side. So all of this is the left side, all of this is the right side. Now, this left side looks really complicated. It's big, there's a lot of stuff to it. So before I get to the actual act of solving for x, isolating the variable x, getting it all by itself on one side of the equal sign, I am going to make it simpler. So I'm going to simplify it. And as I'm looking for things to do to simplify it, the first thing that I see and the easiest thing that I see is right here. I see these two numbers that look like regular numbers that I've used since grade school. Very familiar with those two numbers. And so I can think of those, pulling them out and looking at them and going, I have a plus 6 and a negative 2. And if I were to add those two together, it'd kind of be the same thing as 6 minus 2. And so I can put those two things together. I'm going to reorder my algebra sentence here, which I'm always allowed to do as long as I keep the signs the same. So there is me reordering it. I'm going to look right here. So if I were to take away everything in front of that, I have this little expression right here that says 6 minus 2. 6 minus 2 is 4. 4 is an easy thing for me to think of, so I'm going to exchange these two numbers right here for a 4. And everything else in my statement, in my algebra equation, is going to remain exactly the same. Give me a smiley face if so far this seems okay. If you've got any questions about why I did something or how I did something, now is the time. Please give me a shout out on the chat thread. Give me a smiley face if everything is okay. And ask your question if you are confused. Give you a couple seconds to make that happen. Don't see any questions coming through right now. So if you've got any questions, again, please speak up. So I'm going to continue on, and I'm looking at this and I'm looking for other things to simplify. And the next thing that I see to simplify is going to be these two things right here. And the reason I'm looking at these two things right here, wow, this yellow doesn't show up very well. The reason I'm looking at these two things to simplify is because they kind of look the same. They both have a number, and that numbers are from both of them, that number is being multiplied to the same letter, the same variable. In this case, the variable x. So I have 2x's plus 4x's. I can add those together just like I would any other normal number. So I have 2x's right here, and along comes 4 more x's. So altogether, I have 6x's. So 2x plus 4x becomes 6x. And that's the only thing I'm going to change in this algebra statement. Now, if I look at the left-hand side of the equation, I'm going to notice that I can't really do much more to it. I can't add the 6x to the 4 because the 6x has a variable and the 4 is just a number. So I can't simplify it anymore. So now I need to get to the process of solving, of actually isolating the x, getting it all by itself, and that will reveal what value it has to be to make this sentence true. I know some of you have been taught the guess and check method where you just start at the number 1 and you just start randomly guessing numbers, sometimes in a systematic way in order until you get to 28 equals 28. Not the method we're going to go with here. We're going to very by the rules, kind of like we're opening a present, unwrap the numbers until we get to what the value of x is. Now, as I'm looking at this particular sentence, I'm going to look for things that I want to undo, and I'm going to do that in the realm of, or with the lens of, the order of operations. So I'm going to take a very quick detour, and I'm going to talk about the order of operations. So I'm going to scoot over here. And the order of operations are usually some sort of grouping symbol. So like parentheses, square roots, absolute values, those kinds of things. Followed by exponents. So those are the little numbers like squared things. Followed by multiplication or division. They have the same kind of weight. And then addition, subtraction. Okay, so those are our typical order of operations when we know what the number for x is, and we're going to use that in a sentence like this to figure out what it should equal. But I know what it equals. I'm trying to figure out what this is, so I need to do the order of operations in reverse. I need to go backwards. So as I'm looking at this and I'm trying to wonder, which one should I get rid of first? Go to your order of operations and start at the bottom. I should get rid of addition and subtractions first. This 6x, yes, I agree, being added to the 4, but this 6x isn't one thing, it's actually two. It's a 6, and there's an operation to the x. When you don't see an operator symbol, like addition, subtraction, multiplication, division, it's written like this. When you don't see that, automatically assume it's multiplication. So this 6x represents 6 multiplied to x, 6 times x. And so this 6x thing is going to be sitting on this level right here, the multiplication division level. Since I have this addition by 4, that's sitting right here at the addition subtraction level. So I have to get rid of this piece first. So now I know what I want to get rid of. The question is, well, which operation should I do? Should I do addition or should I do subtraction? This symbol right here tells you. This is addition. You undo addition by subtracting. So I'm going to subtract 4. I'm going to subtract. I said by 4. But let's talk about why it's 4. So I'm going to subtract. That gets rid of this addition. Well, how much am I trying to get rid of? I'm trying to get rid of this 4 right here, so that's what I need to subtract by. So I'm going to subtract by 4. This is like a balance beam. So what I do to one side, I have to do to the other. Otherwise, it's not going to be balanced, and the whole thing's going to go blah, and fall and break. So what I do to one side, I have to do to the other. I'm going to put my little bars here to help me keep track of what I'm doing. Plus 4, minus 4, those cancel because 4 minus 4 is 0. It's exactly what we wanted to do. So then I am left with 6x. And I'm going to put that over here. I know it kind of looks like I'm putting it under the 4 minus 4, but that's not really what I'm doing. There's a 0 there, but since I don't need to add by 0, I'm just going to pretend it's not there anymore, and I'm going to shift that 6x over. 28 minus 4 is 24. And so we are left with 6 times x equals 24. So I have gotten rid of all of my addition subtraction things, and the only thing I have left is multiplication and division. Because this is multiplication, 6 times x, in order to undo multiplication, I need to use division. So I'm going to divide. What am I trying to get rid of? I'm trying to get rid of the 6. So I'm going to divide by 6. What I do to one side, I have to do to the other. So over here, I'm also going to divide by 6. I'm pausing to give you just a moment to catch up. All right. Looking here at the left side, I now have 6 divided by 6. Well, 6 divided by 6 is not 0. 6 divided by 6 is actually 1. But 1 times whatever you have here doesn't change that value. So I'm still going to be left with an x. I don't know what the value of x is yet, but I know that 1 times whatever this is going to be isn't going to change it. So I can write just x. If you really want to write the 1 there, you can, but it's not necessary. You don't have to write it. On this side of the equal sign, 24 divided by 6 is 4. So now we've isolated x. It's all by itself on one side of the equal sign because I don't need to write this 1 there. So it's all by itself. And now that it's all by itself, it's isolated, it has been solved for, and its value is 4. And this is how you use algebra in order to help you find the value of things. So that's all well and good, but we still don't know what the length of AB is. What if the question had been, here's your given information, what's the value of AB? Well, we've done all this work. We've uncovered what the value of x is, but I still don't know what the measure of AB is. But I have this algebra expression, 2x plus 6. Whatever the response to that expression, when I plug in what I know for x, that is the distance between A and B. So I'm going to substitute what I know. 2 times, and I'm going to replace the times with a parentheses. So 2 times whatever the value for x is, the value for x was 4. So 2 times 4 plus 6. And now I use my normal order of operations, which is over here in the purple. Grouping symbol, everything inside parentheses are absolute values or square roots. I don't have any. Well, I have parentheses, but fours, there's nothing I can do. It's just a 4. Exponents, I don't have any exponents, no squares or powers of 3 or anything to deal with. Now I'm in the multiplication division layer. I have a multiplication right here. 2 times 4 is 8. 2 times 4 is 8, and then I'm going to write what's left is plus 6. And now I have just these two numbers. 8 plus 6 is 14. And so the measure of line segment AB is 14. You can use the exact same concept to find the distance between points B and C, the measure of line segment BC. I'm not going to do that with you. The process is exactly the same as here. You're just going to use slightly different numbers. The value of x won't change, however. So I use the value of x here, and I will use the same value of x over here. I'd like to go in and introduce the angle addition postulate.